Okay, we're going to be solving exponential equations, and I put that this is the assignment because, you got a video of the notes. So let's jump in here. We got the assignment. Number 1, 7 to the x minus 4 power equals 7 to the 8th power. Since our bases are the same, we can essentially ignore them, and it's x minus 4 equals 8. You add 4 to both sides, and x is going to equal 12. If you are just looking at this for the first time, I really recommend you go back and watch the notes because I really kind of delicately put it, in my opinion, how this is right and why it's right, as opposed to just, hey, believe me, that's it, okay? Number 2, same bases. So we ignore the bases and we do the exponents only. 4x equals x plus 9. We're going to subtract x to get 3x. We divide by 3 to get 3. Okay, number 3. 3 to the x power equals 243. Oh no, they're not the same bases. However, this is what we've been training for. Is we're going to change 243 to be 3 to what power? Well, here, hang on. 3 times 3, that's 9. 3 times 3 times 3, that's 27. 3 times 3 times 3 times 3 is 81. And 3 to the 5th is 243. So, we have 3 to the x power equals 3 to the 5th power. And now they are the same bases, so we ignore the bases, and it's just x equals 5. Number 4, 216 is our base because it has an exponent. 6 is our base. Well, okay, we can't do this right now because what if the bases aren't the same? Well, so we can try and change the bases. So 6 to the 3rd power, don't know what just happened. 6 to the 3rd power is 216. If you don't believe me, do 36 times 6 real quick. And so what we're going to get is 6 to the 3rd power, because that's 216, like I just said, and that's going to be raised to the x power, that one right there, right? And this guy's on the outside because he was affecting 216. Well, this is 216, just written in a different way. So now we can rewrite this whole thing to be 6 to the 3x power. How come? Because when you raise a power to a power, you multiply the powers. And then now, our bases are the same, so we can ignore them and just do 3x equals x plus 10, subtract x, divide by 2, and x is 5. 27 to the x power equals 9 to the x minus 2 power. Well, I can't write 27 as a power of 9. I can, but I really don't want to. So what I'd rather do is 3 to the 3rd power is 27, and 9 is really 3 to the 2nd power. So I'm going to rewrite both of these bases is what I'm saying. So this one is now 3 cubed to the x power. How come to the x power? Because he was already there, right? And that x is affecting this whole thing. And now, yes, we can redo this or rework it or distribute it, however you want to say it. A power to a power multiplies, right? This 9 becomes, here I'm going to write it up here, 3 squared, and that's being raised to the x minus 2 power. So again, power to a power, multiply the powers, and we're going to get 3 to the 2x minus 4 power. How is it 2x minus 4? Because 2 times x is 2x, 2 times negative 2 is negative 4. There you go. Oh, look, our bases are the same now. We can just focus on the exponents. So 3x equals 2x minus 4. Subtract 2x to get x equals negative 4. Done. Negative 4. Next. Oh no, another similar scenario where both sides do not have just easily accessible exponents or bases. Well, I can rewrite this as 2 to the negative 2 power. Don't believe me? Well, then watch this. It's really 1 over 2 squared, which I don't really want to do 1/2. I don't know. So I can actually make it look like that, which would then do this. It'd be 2 to the negative 2x power. And the reason I did this is because 256 can be written as a power of 2. I believe it's 6, but let's try it out. So 2 times 2 is 4, times 2 is 8, times 8 is 16, 32. I was way off. It's 64. So to the 7th power is 128. To the 8th power is 256. So we have 2 to the 8th. If this is confusing, I literally just started writing 2's and then multiplied them. So 2 times 2 is 4, times another 2 is 8, times another 2 is 16. This is not like any specialized method. This was some math nerd writing times 2 to himself. So now we have 2 to the negative 2x power equals 2 to the 8th. We can ignore the bases because they're the same. Negative 2x equals 8, so x equals negative 4. Next, we have 3 to the 4x minus 9 power. Well, I am really motivated to rewrite this as a power of 3. So first thing I'm going to do is write 243 to the negative 1 power, because that flips this, right? And now over to the side, I know that here, hang on, did we do 243 already? We did. 3 to the 5th is 243. You know what's funny? I knew it up there, and I didn't know it down here. So here's what we have. This is 3 to the 5th to the negative 1 power. How come? Well, because this is 243 to the negative 1 power. So basically I said, hey, listen, I'm going to rewrite 243. So notice I slapped parentheses, and then negative 1 is outside of there. Sorry, there's random noise because I tutor on Wednesdays, and I'm at Panera, and I just have a time to record the video, so here I go. All right, so the right side is this. Well, I guess really it's this, right? The left side is this. We can now ignore the bases and just focus on the exponents. 4x minus 9 equals negative 5. Add 9 to get 4, and x is 1. That's not bad. Okay, this seems a little less fun, but again, it's just rewriting things. In fact, we can kind of cheat and go back and go, hey, look, 27 and 9. It does work. So 27, 1 over 27 is really 3 to the negative 3 power, and that 4 to the 4 minus x is out there. 9 is really 3 squared. Raise that to the 2x minus 1 power, and now we can multiply those to get negative 12 plus 3x. We can multiply these to get 4x minus 2. And now it's just a little bit of algebra. So I'm gonna, let's subtract 3x to get x, add 2 to get negative 10. X is negative 10. Got some errors. Describe and correct the error, okay? So 1/8, here's the error, but right away. 1/8, if we were to flip it, it would be 8 to the negative 1. And that would turn into 2 cubed to the negative 1, which would turn into 2 to the negative 3rd power. It's right there. That's the error. Okay? So if we were to continue, then that would need to be the negative 15th, right? And this would need to be negative 15 right here. And let's see. So when we subtract 5x, you get negative 20x equals 40, and x would equal negative 2. So we could have figured that out. I'm sorry, that's the error. It's just that negative. Sounds like a mistake I would make. if I ever made math mistakes, right? So I just finished making an awesome joke and found out that this is printed wrong online, and obviously in this PDF, it should be like this. So I left you a warning on the slideshow, and obviously there's a warning right here. These graphs right here, this graph is correct. But if you were to try and do it as it looks right here, you will not have success. So I realized I can't cross that out because that's a highlighter. So that's wrong. This is right. And yes, the answer is -1, okay? So don't waste 5 minutes like I did thinking that you'd gone crazy or that I'd gone crazy. Solve the equation, select all that apply. So we have, they have 1, 2, 3, 4, 5, 6 answer choices. So here's what they did up here in case you didn't watch the video. They took this piece and they graphed it. They took this piece and they graphed it. And literally in the notes it says, hey, do that, but use technology to graph it. So I'm pausing the video because I'm gonna go hop over to Desmos and do that. Okay, so here it is. 1.9 to the x minus 4 power is that red line, and y equals 3.61 is the green line. If you got the Desmos and you just tried typing in 3.61, like let's say you put it right here, it didn't do anything, that's because it was like going, hey, they want this. It gave like that kind of looking symbol over to the left, and no matter how many times you tried to click it, it didn't do anything. So you actually, in order to put it on the graph, have to say it's y equals. Now, if you did x equals, you would have gotten something like right here, and you would have been wrong, because as we did, or maybe as you saw in the notes, that what you do is you take each of, zooming is not working, you take each of these and you do y equals this thing, and you do y equals this thing, okay? Because it's not what x equals, it's what y equals. And so it's 6. X equals 6. And if you're like, but you just said it's not about what x equals. If y equals both of those, then we will get x. And so our answer is 6. Next one, solve the equation, select the solution. Same thing. We're going to take this piece, y equals 4x minus 3. We're going to take this piece, y equals 5 to the x minus 1 power. We're going to graph them both. And we're back. So again, if you watched the video notes, at the end, I did that last problem where I said, hey, you can watch this one if you want to, or if you feel like you got it, go for it. I would have recommended watching that last one because it ended up being solved in 2 spots just like this one. And if you're not sure how that's possible, plug in 1 to both of these different x's and see what happens. Plug in 2 to both of these different x's and see what happens. Here's what I did not say. Plug in 1 on one side and 2 on the other. Don't do that. Plug in 1 on one side and 1 on the other, like here and here, and see what happens. So the answers are 1 and 2. Solve the equations, select the solutions. It looks awful. I don't want to do this, but that's not what we are tasked with. We are tasked with problem solving, and we can solve this. And in fact, I'm going to show you one reason why you think this one is so hideous is because it's just written ugly. Like if we were to rearrange this, it's really y equals 19/4 minus 15/4 x. So like this is technically in slope-intercept form. There's our slope. This is our y-intercept. So the y-intercept is 19/4, which is a little less than 5. And that slope is negative 15/4. It's ugly looking, but it's not as crazy as you think. That's, I guess, besides the point. We're going to go over to Desmos now and graph this. All right, we're back. And this is another one where there are 2 solutions, -3 and 1. So -3, 1. Cool. Solve this equation. If you look at your answers, I mean, it looks like we might have something nifty on our hands. Again, we're just going to take that side and that side, plug them separately into Desmos. Here I go. Okay, I zoomed way out. Let me zoom way back in. The answer is 1.4747. So, looks like we'll go with that one right there. I believe this is the last one like that. Again, we're going to put that on one graphing portion of Desmos, that on the other. I'll be right back. All right, we're back, and this is no solution. These guys don't cross. The red one, as you can see, just goes whoop, like that, and the black one just goes like that. Whoop. So this is no solution. Okay, so I think that's the last one like that, and after that, now we're actually going to be doing some for real solving. It's just they start to get a little bit hairier, right? So here we go. Okay, so I moved over here thinking I was going to need some more room, but now I realize here's what's going on. We have 12 times that equals 24. Well, you know what? I can just divide this side by 12 and divide this side by 12, and I get 2 to the x minus 7 equals 2. So the bases are the same. I look at the exponents. There's an invisible 1 right there. So it's just x minus 7 equals 1. It's just x equals 8. That was so easy. So very similar here. I'm going to divide both sides by 2. And if you're like, whoa, that is really jumping in there for me to, to see what's going on here. Basically, what's going on is we can't solve these unless they have like bases. And if you're like, wait a minute, we could solve these and they didn't have like bases. That's true. You could plug these into Desmos and do it, but that's not what we want you to do. So we want you to be able to solve them. I mean, look, by the property of equality for exponential equations. So there you go. Divide by 2, those 2's cancel, and I get 4 to the 2x plus 1 power equals 64. Well, hey, 4 to the 3rd power is 64. Now, you might have thought, well, wait, should we write them as different, like as the base being a 2? No, you don't have to. So this is 4 to the 3rd power, and these are now, you ignore those, and it's just 2 to the x plus 1 equals 3. And I kind of stumbled over my words, saying, does it have to be a 2? Does the base have to be a 2? Here's how that would have differed. This would have become 2 squared raised to the 2x plus 1 power, and the right side would have become, 4 to the 3rd is 64, 2 to the 6th is 64. Okay, and then yes, you would multiply those. So here's what you would get. You would get 4x plus 2 equals 6. You tell me, how are these two different? This one is multiplied by 2 on both sides. That's the difference, okay? So anyway, you subtract 1, and you get 2x equals 2, which is just 1. Modeling real life, a bacteria culture quadruples in size every hour. Neato. So you begin observing the number of bacteria 3 hours after the culture is prepared. The amount y of bacteria x hours after the culture is prepared is represented here. After how many hours will there be 200,000 bacteria? So this might seem very freaky, but if we just zoomed in here, what we've been doing is stuff like this. We've been doing stuff like this where we had an account, and that equaled the principal amount times 1 plus r over n to the n times t. So this isn't much scarier. In fact, I've been trying to tell you that this is what we have. This is like our parent function, and these are just versions of that. So what has a been this whole time? The initial amount. Look, there's our initial amount. There's our initial amount. What is this, though? That was how much money we made over time. So we want to know When will we make $200,000? No, not really, 200,000 bacteria. So here's what we're gonna do. We're gonna take this, and it's 200,000 equals 192 times 4 to the x minus 3 power. And now this is like what we've been doing, in that I can divide both sides by 192, okay? And I don't know that off the top of my head, hang on. You get 1041.6 repeating, and that equals 4 to the x minus 3 power. Well, we can't change that to be a base of 4. So this is where we're gonna need to actually go graph it. So here's the funny thing about this. Technically speaking, we don't have to graph this. We could have graphed this, and on the other side graphed this, right? Like in the calculator or on Desmos, but let's go ahead and do this because you just didn't know. Maybe this could have worked. You know what I'm saying? So let's hop over to Desmos. All right, I hopped over there, did that, and here is the graph. Now I'm gonna sit here for a second because I kind of have to explain it. Our initial value for this is 1, so it's way down here. And this is 1041, right? So it's way up here. And so this graph looks ultra funky. It looks like it's just a right angle. It's not. But it basically will reach 200,000 in 8, I don't remember what our unit of time is, 8 hours perhaps. And if you're like, well, big deal, we didn't have to do all that work. You may be right. We maybe didn't have to do all that work, but you would have had to have zoomed up 200,000. So for what it's worth, anyway, the answer is 8. 8. All right, solve. We got 81 as our base, 3 as our base. We can make those work. So we have 3 to the 4x plus 3. 81 is really 3 to the 4th power. We need to go ahead and put that x outside there, and we're going to multiply those powers. So we get 3 to the 4x plus 3 equals 3 to the 4x. Uh-oh. Ignore the bases, and you get 4x plus 3 equals 4x. What's going to happen here is you subtract 4x, and those cancel, giving you 3 equals 0. There's no solution. They are essentially parallel, right? This one is just moved to the left 3 from that one. So that is no solution. Solve this equation. Okay, well, let's see. 625 is really, let's see, 5 times 5 is 25 times another 5 is 125. Okay. That's 625, which is 5 to the 4th. So we have, this one is kind of written in an annoying looking way, 8x minus 8. And then this one is 5 to the 4th, and then 2x minus 2 like that. So now we distribute that, and we get 5 to the 8x minus 8. Oh, so this one's interesting. When will this left side, which looks like that, equal this side? Always, because they're exactly the same. This side is this side. You would not have known it looking at that, right? And hopefully you didn't just go graph that and then graph that, because that would have been kind of frustrating. There are a total of 128 teams at the start of a citywide 3-on-3 basketball tournament. Half the teams are eliminated each round. Write and solve an exponential equation to determine after which round, x, there are 16 teams left. Okay, so 128 at the start. Well, here's what I'm thinking. It's going to be y equals a times b to the x. There's 128 to begin, and each time there's half raised to the x power. So let's see. Let me see if I'm missing anything. Total of 128 teams. Half the teams are eliminated. We want to know when does it equal 16. Okay, we can do this. So, first thing is, we would love to have 1/2 as our base, but we don't right now. And when I say 1/2 is our base, I mean like if this was 1/2, but it's not. So what we're going to do is divide both sides by 128, okay? So let's see, if you divide that by 4, you get 4 30 seconds. If you divide that by 4, you get 1/8. Okay, I can handle that. 1/8 equals 1/2 to the x power. Well, check this out. This is really 1/2 to the 3rd power. And I know this might feel a little strange, but what's the difference between this and this? Nothing. So we have 1/2 to the 3rd power equals 1/2 to the x power. We have the same bases now, so our answer is 3. Oh, and by the way, this was our exponential equation right here, and the answer is 3 for when will there be 16 left. The graph shows the annual attendance at 2 different events over time. Okay, let's take a look at this. So event number 1 is blue. All right, it goes up, started at 4,000, definitely exponential growth. The green event started at 12. This is decay because this number is between 0 and 1. Estimate when the events will have about the same attendance. Well, it's right there. So about 3 years after, right? And after 2010, so that's 2013. Oh my gosh, all they want to know is how can you verify that? How can you verify your answer? Okay, so other than look at graph, what you could do is what we've done a handful of times tonight, is you would graph that on Desmos, graph that on Desmos, and then see exactly where they cross. So I did that, and here is the graph. By the way, the graph is insanely hard to read if you don't have a good window. And if you're like, what's a window? What I mean is I made my bottom part 5,000, my y-axis, sorry, the bottom part of my y window 5,000, the top of it 13,000, and then this is 0 to 8. So here you would think, oh yeah, it was exactly 3. No, 3.03144. So in the grand scheme of things, yeah, it's 3, right? But if, let's say, you needed to be insanely accurate, this is how you do it. So that was solving exponential equations, the assignment. Let me know if you got any questions. See ya.